Hey, broke down bones, dust in the air, eyes to the ground, no one cares. Empty streets, whispers bite, lost my way in the dead of night. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. Gonna find my way back to the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. The shadows laugh, but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no change, no lie. Gonna find my way back to the top. Hey, broke down bones, dust in the air, eyes to the ground, no one cares. Empty streets, whispers bite, lost my way in the dead of night. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. To the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top.
All right. Good morning, good afternoon, good evening, folks. This is Mike from Unknown Tech, and you're joining the Architect Podcast. And this is episode 15, so welcome. I'm glad that you're here. And today we're going to have some more fun with our do-it-yourself DGX Mini-Workstation that I built. We'll talk a little bit more about that. I know last week we went into some of the demos. One of the things that didn't work out so well was the NIM demo, and I'm going to actually start with that, because I did fix that. And really what it was my NGC key was incorrect. So I had to update the NGC key, so I was able to pull the images from NVIDIA NIM. So we'll start there, and we'll go to the DGX system. And so let's go there quickly. But before we do that, I want to remind everybody that this podcast is actually a part of a broader blog and website that I have called unknowntech.io. So I just want to point this out here. If you go to unknowntech.io, it'll actually forward you to WordPress. And this is the main blog site. So you can go to unknowntech.io and you'll get the main blog. And I have articles of all the things that I've done, as well as links to all of the past live streams, podcasts, etc. Right? So now, this is more of a live stream versus a podcast. The podcast, I actually have guests. I actually had one podcast where I brought in Damon, who's our AI expert within Nutanix, and we talked about all the things AI at that time in episode 6. That was a while ago. But if you want to go back and look at some of the podcasts that I've done or streaming events that I've done, you can actually go into the website, and actually they're all linked here. This was last week's where we actually went into the DGX workstation. The DGX workstation is actually built in this 3D case here, and it's sitting next to my little mini rack here, so right in my office. So this is what's nice about this. I tried to keep it as close to the DGX Spark size as possible. Obviously, this is bigger. It's very difficult, though, when you don't have custom ASIC, right? So I actually work with mini ITX components, Flux ATX power supplies to keep it small. And, of course, I have a low-profile GPU, which is the RTX 4000 SFF Ada GPU within this machine. Pretty powerful machine, 24 cores, 96 gigs of RAM. I want to say up to, I think, 6 terabytes of NVMe storage and the RTX 4000 SFF Ada. One thing it doesn't have, though, is a fast networking. It only has 2.5 gig networking. In actuality, I could add a 5 gig, it has 5 gig networking now. I take that back. I actually installed a USB-C QNAP 5 gig networking device that I had from my previous desktop before I got 10 gig in the office. And so now it's at 5 gig networking, but still 5 gig is not a lot. But the reality is I'm servicing the models locally, right? I'm feeding the data in the models locally on the machine. So I'm not concerned so much about network throughput. If I were to cluster a couple of these together, yeah, that would be a requirement to have very high speed networking, but I don't have a cluster. So I'm dealing with a single machine. So the 5 gig networking is fine. So again, you have all of these articles you can go to, and they're segmented out, right? So I have, articles based on cloud native technologies, emerging technologies, Gen AI, platform engineering, right? But you can go to the website and you can see all of the articles that I've written. And it's not short form content, right? It's long form content. I haven't got into short form content yet. I actually will be soon on the YouTube channel doing like different like how-tos, right? Or things I've learned along the way from a short form perspective. But I want to build an AI workflow to actually do that for me. And so I'm actually going to do that with N8N. That's another project I have for the holidays and into January, February. But the reality is as I focus on AI more, I want to be able to use AI, right, in the lab. Part of that is using automation, right, and agentic automation, right, within the lab. But also part of it's also delivering some content. And of course, it won't be, just AI doing the content because that's not original content. I mean, it is, but it isn't in a sense. It's not, there's no originality coming from me. But what I'm going to do is I'm going to focus on the content, focus on the media side of it, the creation of the video, the music on the back end for AI to build that. But the content itself will actually come from me. Okay. Again, we don't want to use AI as a crush. We want to use it as a value add, right? That's the goal. So another thing, and you probably don't see the webpage, but here it is, unknowntech.io. Let me just go here really quick, share my screen. Okay. So I apologize. Unknowntech.io, WordPress.com. You can just use unknowntech.io and it'll forward, Cloudflare will forward it to that IP address. And again, these are the articles that I've written a bunch, right? And again, if you quickly go to the live stream podcast link, you'll see all the previous live streams and podcasts that I've done up until last week. I actually just uploaded this morning and linked this on the webpage this morning. And so this was last week's. Again, this is a DGX workstation that I built here. So, okay, let's go back to, let me close this out. And I want to go back to the actual DGX workstation itself. So last week you saw me try to run NIM models, and I had an issue with that. And then I ran Olama, right? Because I have Olama installed on here, and I actually downloaded, I think, GPT OSS 20B. Now, you're probably thinking, why not 120B? Of course, again, it goes back to the trade-offs of what I built here, right? I don't have an official DGX Spark solution, right? Which is something I'm thinking about, by the way, contemplating on getting. I'm not sure if I'm going to go down that path. I'm not sure if I really need something like that, but I'm thinking about it. And of course, if I do that, you guys will be the first to know, and I'll post a lot of content on that. But just focus on what I've built so far is, I only have 20 gigabytes of VRAM, right, on the RTX 4000 SFF Ada. It's a pretty powerful GPU, But since it's low profile, I'm bound at 70 watts as well. So it's not as powerful as the thick version, right? The full version of the RTX 4000 ADA GPU. It's a low profile version, so it's bound to 70 watts from a power usage perspective. And because I'm bound to 70 watts, the memory bandwidth, right, and the GPU capability is actually less than the standard RTX 4000 ADA. All right, so if you're looking at buying, cheaper parts, cheaper solutions, I talked about this last week. You really should focus on, and you don't care about form factor. I think this is the key. If you care about form factor, your options are limited. If you don't care so much about form factor, then you can go with, RTX 3090s as an example, right? And you can have those. I think the last time I looked, they're at 800, so they're going up in price because of AI requirements, right? People buying these up, right, for local AI, and they used to be 600. But you can buy a couple. You can go quad 3090s if you have the right platform, and you're going to get 96 gigs of VRAM or 48 gigs of VRAM respectively, because they each have 24 gigs of VRAM. And you can get pretty good performance on the 3090s, right? So again, for the cost of 12, $1,600, let's just say 12 to 1,600, right, for 3090s, right? You're still at half the cost, less than half the cost of the DGX Spark. Now, the trade-off again is the VRAM, right? You're getting 128 gigs of VRAM, unified memory on the DGX Spark. And to be honest, I go back to what I said before last week. Who is the DGX Spark made for, right? What are the use cases it's for? It's not for production. I've seen people post already on Reddit, of course, of all places, that they're using these things in production, and that's not really what it's for, right? It's for developers, for AI developers, data scientists, to test their applications, to test their workflows, to test their blueprints, validate models, all of those things, right? It's not for performance. And so when people say, "Oh, I got a DGX Spark," and they're talking about inference, I cringe, because that's not really what it's for. It's not just for inference, right? It's for many different things. You can actually fine tune on it, and you can actually do much more on that thing, right? Especially with the floating point 4 performance. It's actually pretty phenomenal for the size. Now, knowing what it is, right? Knowing what it's the use cases, what it's used for, right? Then it goes to the question is that something that I really want or need? And in my case, more than likely, no. I'm not an AI developer. Okay. Now, you can be a enthusiast like myself, an AI enthusiast, right? In an AI and an AI, I'm more on the inference side because I work at Nutanix and we have an AI platform, which I've talked about before and I showed you guys, right? Those solutions are enterprise grade solutions, and it's more on the inference side, more on model operations, endpoint operations, right? And I'm very focused there. Don't get me wrong. And I'm digging deeper into AI. And so if you want to move and make that move, and you really want to focus on NVIDIA technology, since they seem to be not seem, but they really are the number one player in the market right now, right? Of course, China's coming in fast, hot and fast. Again, I hate to kind of diverge into conversations, but talking about this, right? Jensen just did a podcast with Joe Rogan, and regardless of what you believe politically, as far as Joe Rogan's concerned, doesn't really matter. I was curious to see what Jensen had to say. And it's actually pretty scary where China is today from from catching up perspective, right? Especially in the silicon, right? With Huawei, right? They're not that far behind NVIDIA. And the manufacturing prowess of the Chinese, right, is pretty formidable. And the government is 100% backing them, especially in the energy front. Again, I went off on a tangent, but I just want to say that, based on, you wanting to learn NVIDIA, right, that's good, right? Because NVIDIA really, especially with CUDA, again, I said the power of NVIDIA is not just the silicon, it's CUDA, right? Nothing comes close to CUDA from a framework perspective, because CUDA's been around for a long time. It's mature. They continue to innovate. They just released CUDA Tile. I won't get into that right now. You can check it out. But they just released CUDA Tile. And I think it's very, very important to understand that how important CUDA is from that perspective. But if you want to go from an enthusiast into more AI development, then the Spark may be for you, right? And so I'm not saying that an enthusiast shouldn't buy it. And of course, if you have the money and you want to play around and you want to, it's more of an enablement type solution, and that's where I would consider it for myself, to be honest, then I would go down that path, right? Okay, so I know I talked a lot about that, but I just wanted to kind of revisit where we were with NIM models on the my do-it-yourself DGX Mini-Workstation, and you can see my screen now. I actually have a model running now from NIM. So I ran the Docker command. I fixed the NGC key. I ran this Docker command to actually load up Llama 3.1 Nemotron Nano 4B version 1.1. And it created the Docker container, right? And it became available, right? And you can see here when it becomes available, it basically is ready to be used from a service endpoint perspective. And you guys do know that I have, and by the way, let me go to an NVI top. This is another utility that I use. You can see that now the RTX 4000S FF8 is fully loaded up, actually using almost its capacity of VRAM. I have a gig remaining in VRAM. So basically I'm using 19 gigs of VRAM for this model. You can see the temperature. And so this is nice to actually use when you actually use it. NVI top. People say, well, you can use NVIDIA-SMI. You can too, but NVI top gives you much more granularity in the GPU side as well as the CPU side, what processes are running, swap file utilization, GPU utilization, all of that, right? That's why I use NVI top over NVIDIA-SMI. So if I go back here, you see this model is running. And now if I go to Open Web UI, and let me make this bigger so you guys can see it. But essentially in Open Web UI, you can see now that under my dropdown, I have the NVIDIA Llama 3.1 Nemotron Nano 4B. Okay, now if you remember last week, if you watched last week's episode, if you use Ollama, there's native integration of Ollama into Open Web UI, right? And because of that, I can see what models are active. Like if I had a Mistral 7B running in Ollama, you would see a green dot next to it that it was running. And you would also be able to get the metrics, right, from the model itself. So when you do a chat, an inference against the model, right, you will get the metrics back of time to first token, how many tokens, all of that. Latency, right? You will not get that on the NIM model. So I want to be very open and transparent what you're not going to get on NIM versus Ollama running on this platform. And that's the reason, by the way, one of the reasons why I selected to use Ollama as well as NIM models on this DGX Spark Mini-Workstation, the do-it-yourself Mini-Workstation, because I wanted to get those metrics. Now, you can get the metrics from NIM, but you need tools, right? You need to enable OpenTelemetry, Prometheus, maybe have something like Grafana, right, from a visualization perspective. You can still do that. So you can feed that back into a Grafana instance. I could run that all on this Spark workstation. I don't want to do that though, right? I do have Grafana, et cetera, and Prometheus set up on another platform, on Nutanix actually, and I could feed it into that if I wanted. And I'm thinking about doing that. I haven't thought about it yet, but it would be nice to get some of those metrics that you get with using the Ollama models here. You can see I have Mistral 7B and GPT OSS 20B. Those are two of the models that I have downloaded for Ollama. The Arena model, I didn't talk about this. So I can leverage the Arena model chat request, and what it'll do, you'll submit your question, right? And it'll fire up both models and use it against both models, and now you'll get a comparison as to which model's better. I love that feature, right? Because now I can set my context. I can do a like-for-like context and ask against two models, right? And get a validation of the performance. And so that's a pretty nice feature as well from Ollama. But now you see that I have NVIDIA Llama Nano B, and so let's ask it a question. Write me a brief story on how AI started. Okay. So one thing that I've noticed as well with the NIM models is that it's not showing me the chain of thought, right? It's not showing me the reasoning process, even though in my settings, if I go back to settings here, right? You can see here in my context, my system prompt, right? I have, right, told it to output the entire chain of thought before the answer. And so I've noticed that on NIM models, this doesn't work very well unless I go back in and say, if I go back and say, you didn't show me the chain of thought, right? So now it's going to go and it's going to tell you what that was. In Olama, you'll be able, it actually has a drop down, right? Where you actually see the reasoning happening on the back end, and it will, it'll show you you'll be able to drop down, it'll save it, and you'll be able to do a drop down and see the actual reasoning and decision making it went through. So that's another difference between using NIM and Olama models on OpenWebUI. The fact is that OpenWebUI has a lot of integration with Olama, but doesn't have a lot of integration with NVIDIA NIM. Now, I know people are probably thinking, well, Mike, why don't you use something like Llama CPP, things like that? You can do all that. I haven't done that yet, right? I just try to make it as simple as possible to consume, right? To test, to do a different inference, right? You can expose this to external systems. It doesn't have to be OpenWebUI, right? Matter of fact, the NIM is an OpenAI API endpoint, right? And because it is that, and that's a standard that's acceptable across many platforms, I can use N8N to call models, serviced by this. I can use Olama, right, and have it connect to the Olama instance as well. So you're not bound by just being on the system and leveraging these tools. You can use external systems to connect. Because remember, when I set this up, if you go back to my previous blog post articles and videos on how I set this up, I exposed Olama, etc., right, to be able to be hosted, right? It's not a local host connection to the port. It's actually exposed on the interfaces, on the 5 gig interface on this DGX Spark. So now you can connect to it from external systems. So if you're hosting N8N on another server or a Docker container or Kubernetes instance on another platform, you can certainly, as long as the network connectivity is there, you can certainly connect and use those OpenAI endpoints. OpenAI API compatible endpoints. All right, so it's a mouthful. So I just wanted to show you that, and so that NIM models are working, right? And now what I do now is I get out of here, and let's see if I do a Docker PS, and now that model's shutting down, it's terminating, right? And the only thing that's running on here, right, is the OpenWebUI Docker container, right? And that's how I'm connecting to OpenWebUI. Again, I'm exposing that on port 3000 to the IP of my DGX Spark. I shouldn't really show you that, but the reality, it's an internal IP. But I'm giving you this, right, to show you that you can expose that and connect to it externally, okay? All right, now that that's done, I'm going to go back to NVI top and see that the memory has been released, right? So now you have kind of this release of the memory. All the things are freed up. I want to get into what we're going to talk about today. So again, it's 11:20. It's going to be try to be a shorter one, right? I'm going to get into very quickly installing ComfyUI, which is basically I call it a content generation platform. And why I say that is because you effectively can do text to video, text to images. You can do text to audio. There's a whole bunch of things you can do with ComfyUI. Today, I'm only going to show you one example of a text to image, right? Because I don't have anything else installed during this implementation process. I just will be using Stable Diffusion from a model perspective, and because I only have that, I can't do pretty much anything else. I can't do a lot of the video stuff, the 3D animation, or the audio stuff, right? Which I'll be working on getting up to speed. But the goal of this session today, right? This live stream today is to get ComfyUI stood up and validated and tested on the do-it-yourself DGX. Okay, So what we're going to do is here is go back. I'm going to sit here and hit clear. Now, again, you're probably like, Mike, why aren't you SSH'd yet? I still haven't set it up. I guess I'm lazy. I haven't set it up yet. You can SSH into your system and do this all through SSH, but I'm on my Jet KVM. I guess in a way, I think this is pretty cool, the Jet KVM, right? That it's an IP KVM. It's sitting in that. If you go back here, I'll show you. Let me go back here to the picture, right? It's essentially, hang on one second. All right, sitting in I actually have a 3D printed a bracket for the Jet KVM, and I actually just finished 3D printing a dual port because I actually have another Jet KVM that's going to connect to my Ugreen NVMe NAS, and so I'll have two Jet KVMs here, one connected to my NAS in case I need to actually connect to it physically, right? And do operations, and then of course one connected to the Spark, or I call it the Spark. It's really not a Spark, but the DYI Mini DGX Workstation, right? Okay, so let's go back here. There are definitely some prerequisites, right, for ComfyUI, and basically there are 4 prerequisites, right? Actually more than that, but we'll get into the first four. So the first thing is you have to have Python installed. So if we go to Python 3 version, we need to make sure that your Python version is 3.8 or greater. Okay, we have to validate that pip is enabled. Okay, you have to validate that NVCC is there, right? And you need to have the CUDA compiler, and you need to validate that NVIDIA. You don't really need to have this, I don't believe, but one of the prerequisites they say is make sure that NVIDIA SMI is implemented. Now, I don't think it has anything to do with NVIDIA SMI. I think it has to do with making sure you have all the GPU components, right, installed to leverage the actual GPU, which we've already done. We've already done this. Again, if you go back to the first blog post, I walk through getting all this stood up because these are common prerequisites from a NVIDIA perspective, right? And because they're common prerequisites, we did that in the implementation post Ubuntu 2404. We actually implemented, the drivers, right? The Python, pip, NVCC, NVIDIA SMI, which was part of the operator driver package, the NVIDIA Docker Container Toolkit, right? Docker Toolkit, that was implemented. All that was done in part 1 of the do-yourself DGX. So I already had these prerequisites already done. And of course, Docker was already installed, and the NVIDIA Docker Container Toolkit was also already installed. So the first thing we want to do is create a Python virtual environment, right? So what we're going to do is we're going to do Python. You can call it anything, but I call it ComfyUI.environment. And so we're going to actually create that. And now we're going to activate it, right? So we have to do a source, right? ComfyUI. And you can see I've already done this. Of course, I did this to test before. I got on, I had to test this to make sure everything is working right. And I have the right steps before, right? And now you can see here that I activated it. And now in the Warp terminal, you can see I'm in the ComfyUI virtual environment. Okay. So the next thing is we need to install PyTorch with CUDA support within that virtual environment. So install PyTorch with CUDA 12.9 support. So the installation targets CUDA 12.9. So you need to make sure that that's what you're focused on. All right. This is the command, right? It's pip3 install torch vision --index -url, and then the download for PyTorch. Okay. And I'm going to hit enter. All right. Now that that's done, I'm now going to clone the ComfyUI repository. Now I've already done this, so I think this may fail. Let's see what happens here. But basically, you're going to do a git clone on the Comfy anonymous ComfyUI.git. All right, it already exists. So I've already done this. But if it didn't already exist, it would actually clone that repository. And now I'm going to cd into the ComfyUI directory. Okay. Now, step 5 is I have to install the required Python packages for ComfyUI operation. So I'm going to install the requirements.txt. Okay, so one of the things I don't like about JetKVM, by the way, is I can't copy and paste right into the KVM. I have to actually use this paste. So I'm going to show you what that looks like. All right, so pip install our requirement. See how slow it is? I hate that, right? So now we're basically installing the required Python packages for the ComfyUI operation. Okay. Now that we've done that, we're then now going to download Stable Diffusion, right? So we're going to CD into model checkpoints. And now you can see here, I'm actually CDing it into the ComfyUI models checkpoints subdirectory. And now I'm going to do a wget, right, to get the model itself. So I'm going to copy that. Again, I'm going to paste it in here. And now it's going to go through this process. So we're going to do a wget. By the way, in my updated blog post, by the way, you're probably like, well, you got to slow down. In my updated blog post, right, I'm going to link this video, and I'm going to also link the directions on how to do this. Okay, that way you guys don't have to, write this down, whatever, or, copy it right now because I'm going so fast, right? So what we're doing here is we're getting the Stable Diffusion model, okay? And this is going to take a while. Now, this requires a little bit of storage. I think it said that it requires, it says here a 20 gig of storage. I don't think I need all that, maybe, but you need 20 gig of storage. This is not this big though. I think this is only like 2 gigs. Yeah. I don't know where the 20 gig of storage comes from. I think it comes from some of the image creation. Maybe they're saying you should have 20 gig of storage because of the images or videos or whatever the content you're going to create or leverage. Okay. All right. Now that we've done this, we're going to CD out. Not sure where that didn't work. Let's see here. Oh, didn't do a space. Typical Linux, right? Okay. So now I'm back at the ComfyUI subdirectory, and I'm now going to start the ComfyUI web server, and I'm going to listen. Right now, you could listen on the IP address that's the main interface, or you can do a all network interfaces. Okay. So what I'm going to do here, just for the sake of quickness, I'm going to start the ComfyUI web server on all network interfaces. Okay. And now you can see the GUI. You can go to 0.0.0.8188. That's the port. Okay. So basically, ComfyUI has been installed. And if I go now on my web browser and my PC, not the system, right? And I go to basically 10. Excuse me, 192.168.10.199, and it's 81.88. I should get the ComfyUI, and by the way, I have to make this smaller so you guys can see it. I can get the ComfyUI interface. Okay. So now that I've got that interface up, I have a workflow that's already loaded. There's a predefined workflow that comes with the implementation, right? And you can see here, this is the workflow, what it does, right? You have the conditioning, which is basically the prompt, right? And then it's going to clip text and code, and it's going to go through all of these steps, right? And it's going to do it sample, it's going to decode, and then save the image here. All right, so let's close this out really quick. And what we're going to do here is I'm going to use the standard. Actually, you know what? I'm not going to use the standard one. Let's choose one. Let's do a cityscape at night with bright moon and mountain background. Okay. And now I'm going to run it. Before I run this, though, I actually want to bring this up, and I want to go to NVI top here. Okay, I actually had to make this smaller so you guys can see it. And what I'm going to do is I'm going to move this over here because this happens very, very quick. So I'm doing a text to image, and it's fairly quick. Text to image is fairly quick because I'm doing a single pass too, by the way. That's another thing. If I do multiple passes, it's a little bit longer, right? So let's do a run here. And you can see here the utilization of what's happening. Okay, and let's see what this looks like. So the job completed. And now you see what it created, right? And it's actually fairly ugly. Let's go back, make this bigger. Let's do a detailed or realistic cityscape like NYC. All right, let's try that and see what happens. Okay, let's see how this came out. Not much better. Yeah, not much better. Oh, I'm not sure why it's doing that. I may have to go back here. Hang on. Now I should be able to download this, which I just did. Okay. And I think the default is, it's 1024 by 1024. Okay. Yeah, not much better. You got 3 moons here, which is not realistic, right? So again, like with all models, right? There's hallucination that happens. All those things happen. Obviously the prompt is extremely important, right? And so what I want to do is say how much more accurate I can get this. Let's do give me, I shouldn't say give me, accurate. Again, remember I said about prompt, you want to keep it to the point. You don't want to say any unneeded words are just overhead. Accurate view of New York City at night. I'll spell out New York City. Skyline at night with bright moon. Let's see what this does. Jeez, that's actually horrible too. It's better than the last one. Not much better, right? You get the Empire State Building, right? That's pretty close, but like all this gobbledygook at the bottom looks very, very crowded, and that's not really what it looks like. Let me see if I can get this. Make sure that it's accurate with street views and cars. Let's see what happens here. Yeah, not much better at all. But, if you were to say take, maybe 4 or 5 photos of New York City at night, right, and upload that into the workflow, it would be able to use those to kind of generate a more accurate representation, right? Because what is this going off of? It's going off of, it's been trained on world data. It's going off of pretty much world data, pretty much nothing. Not nothing, but kind of this gobbledygook of world data. We want to fine tune that, right? And you can do that by providing, the workflow assets that are similar, right? Or if you wanted to have it give more of an accurate representation, like I said, you could upload 5 photos of NYC at night with the moon as an example, and you would get a more accurate creation of the image, right? So this is just an example of, what did we do? We did two things basically, right? We installed ComfyUI on our do-it-yourself DGX Spark. And by the way, if you have a GPU, a fairly decent GPU, right? NVIDIA GPU, you could easily run this, right, on your machine. You can run it in, I want to go back and talk about this too because it's very important. You can run it in WSL on Linux. I will tell you that you will lose inference performance on WSL, right? There's overhead of Windows. It's virtualized, right? It will work, but you'll lose performance. You can run it on native Windows. That's something that you could do. It's a little bit more difficult, right? I always stick with Linux. And you can run it on native Linux. That's the best way. Native Linux will give you the best performance outcome, and that's what I do. Now, but you're not bound to that, right? So if you have a single machine, like I go back to what I talked about last week, like you don't have to go out and buy all this hardware. I think that's what's really a problem today. Like in all these tech channels, these tech YouTubers, they get people so excited about hardware that people go out and spend their hard-earned money on it when they may already have a machine that could do that can do what needs to be done, right? And again, I'm not trying to take the excitement out of that, but you want to get to a use case, right? And I feel like all these videos, they're fun to watch, but I think what they also do is they're bad for the consumer. And what I mean by that is they're getting more people to buy more and more. I got to have the latest upgrade. I got to have the latest this. I have a 4000 SFF8 I've had for 2 years, right? I didn't go out and buy another GPU, right, to do this. Or if I wanted to do this on my main workstation, I could have done that very easily. Of course, I have a 5090. I know you're probably thinking, oh, well, he's got a 5090, so it really doesn't matter. I mean, I could have done that on my 5090 on my main workstation I'm on now, or I could have done all of this. And so you could do that. I think my point is, my goal is to say that you don't really have to go and build this like massive home lab, server grade implementation, or you're even at a different solution like I have in my mini rack, right? You can do it right on the PC you have more than likely. If you have a gaming system today, as an example, and you want to get into AI, more than likely you'll have a decent enough solution to actually do some of this, right? More than likely. I'm not saying definitely, but more than likely. Like if you have like a 5070 Ti, 16 gigs of VRAM, that's pretty good, right? To actually start with inference. If you have a 9070 or 9070 XT, you could still do it. I mean, even on Intel, like if you bought a B60, that's got 16 gigs of RAM. That's no slouch. You could still do some of this stuff I'm doing, right? So my point is very simple. Don't waste money on trying to keep up with the Joneses. I know that's kind of a saying. You don't have to do that, right? If your focus is learning, if your focus is enablement, if your focus is really trying to understand AI, become more comfortable with it, you don't have to go and do that. If your focus is, I want to, on the flip side of that, if your focus is, I want to host services, you may want to build a small home lab. Again, you could do it in a mini rack on many PCs. You could do it in a PC, like if you want an AI PC, you can build something that I built, right? And you could go even cheaper. You could go with a 5060 Ti with 16 gigs of RAM as an example, right? And still do very well because, again, NVIDIA provides the ability to use, tensor cores, all that in their desktop GPUs too, right? So you can do all that. And so, again, don't go crazy on buying all this stuff. The reason I have a lot of things, I have my rack downstairs and the enterprise gear I have is because it's for Nutanix, for my job, right? And so I focus on that. I use that to demo things. I use it, in customer. Every week I use that in customer activity. So to me, that's a valid solution, right? I'm not hosting anything on that platform, right? From a self-host perspective, I'm just not. There's no reason for me to do that, right? So think about the use cases. Think about like the money that you could waste potentially, and there's a lot of waste out there, especially with the technology industry, especially with like components and desktop components and server components. Again, I really think that a lot of tech tubers are a disservice. As much as their information is good, I believe it's a disservice in a lot of ways to a lot of younger people to think that they have to have the latest and greatest. They have to keep up with the Joneses. They have to have a 5090. They have, right? My gaming system down in the basement is a 5070 Ti, right? It's not a 5090, right? So, and you're thinking, why do I have 5090 here? I told you why, right? I use it for AI, use it for gaming, everything else, right? So it's a lot of different use cases. So I know I went off on a tangent there, but I get concerned when I see like these tech tubers out there. They get this, they're getting this gear, right, given to them from from like Nvidia and Intel and AMD and all this stuff, right? You guys, we don't have that opportunity to just be given gear like that. And I know they're doing it for a reason. They're given for a reason because they're the companies are using them as a marketing engine, right? Which they are. And a lot of people buy things based on what these guys say, right? So just be wary of that. Just be careful of that, and think about what your use case is. And if you have a system that's fairly decent today, even if, like I said, a 5060 Ti with 16 gigs of RAM, you can get in local AI right now, right? 9070, 9060, B60, even the B60 from Intel, which is like $350, I think. That's a great little GPU for inference, right? For AI. And you can do Comfy, all of this stuff, ComfyUI, all that stuff. Okay, so I know I went off on a tangent, but I want to show you what you could do. There's a bunch of templates here. Clear all. Can I select all? Yeah, when I clear all, you can select. There's a bunch of templates that you can do. This is what I like about Comfy. It's not just about text to image. You can do image edits. You can do image to video, right? Now, when you start looking at the requirements, let's look at this really quick. When you start looking at the requirements around these things, right, you may require to have additional models, right, to be downloaded. And that would require a pretty beefy GPU or multiple GPUs to do, right? So I don't think that because these templates are there that you can actually just use them. The workflow that I have here that it comes with, that's just using Stable Diffusion, one Stable Diffusion model, and doing text to image. That's all it is. Okay. Now there's a workflow, there's a decode process, all of that. I'm not saying that that's all there is, but from a model and GPU utilization perspective, it really is regarding the Stable Diffusion model and some of the decoding process, etc. Right. And you can see here more text to videos, photo blueprint to model. That's pretty cool. Imagine uploading an architectural blueprint and it builds out a model for you. That's pretty awesome, actually. More text to video, image to video. These are pretty cool. Image to videos are pretty cool because you can take a picture and pretty much make it come to life. Not, kind of similar a little bit to like how Apple does not very similar at all, actually. But, when Apple, when you go look at your photo, it kind of gives you this little live motion for like a second for the photo. It's not like that, but kind of like that, right? You're taking that image and you're bringing it to life with video, right? One thing I think is pretty cool is this text to song. By the way, all my music that you hear on the intro of my videos or my live streams is all AI generated. Even that rap song that I played at the end, I thought that was actually pretty cool. So that was all AI generated, right? Pretty neat. But you can do text to audio, image to here's Sora, right? So Sora is actually, OpenAI Sora is awesome. The problem with it, it's very expensive. But if you get a chance to play with it, right? Maybe you want to play with it a little bit and don't go crazy. You guys have to look at Sora. It's especially Sora 2. It is awesome. And I think like these are things that are going to completely change the game around what marketing does, right, out there from a content delivery perspective. I think at some point you're going to start seeing, again, I don't know if I'm as excited for this, but certainly start seeing real content like movies, short films, things like that being created by platforms like Sora. Pretty awesome technology. A lot of horsepower on that's why it's so expensive, by the way. It takes a lot of horsepower to create video. Okay. And I think like, especially video that's awesome, like that Sora does, it takes like a lot. I'm talking rack scale infrastructure. I talked about this before. NVIDIA's GB300 NVL72 is an example, right? Rack scale, water cooled, right? 800 gig throughput, InfiniBand, NVLink, spines, right? I mean, just massive, massive throughput, massive video memory in order to do things like this. These are pretty cool. ByteDance is pretty cool, image to video. But you can do a lot of different things, but you have to look to see exactly what's required. What are the requirements to do those things? Okay, so this was a short one this week. I know I kind of went off a little bit. A lot of it was on, showing you how you could use NIM on the do-it-yourself DGX Spark and use Open Web UI to actually connect to that NIM. Then I went to installing ComfyUI. Very, very simple. Is this a production system, right, to host ComfyUI? Absolutely not. I wouldn't run it in Docker, number one. Okay, and if I did, I'd actually have to have, all of the security features, the networking set up, all of that. I would run it more likely on Kubernetes, and I would point it back to a model hosted on an enterprise platform, right, like in Nutanix Enterprise AI. This is for fun, right? The things that we're doing here are for testing, developing, right? App development, right? Things that are non-production use cases. And so you can play around with this. And I'll just show you too how to get out of this, because there's actually a way to uninstall this. So I'll leave here. Go back to my Jet KVM, wherever that is. Did I close it? No. Let's go back here. And so you can stop the server here, and I can now deactivate my Python virtual environment. And now I can go to remove RF, ComfyUI environment, remove -RF, ComfyUI. So essentially what I did was I just deleted, I basically shut down the server, stopped the server, deactivated the virtual environment, and removed the directories, right, that I did the git clone from, or excuse me, to, that created the git, that were created from the git clone action. Okay. So I hope you enjoyed this one. It was a short one, a little shorter than normal. I hope you'll have some fun with ComfyUI and doing image creation on your systems. Next week, what I want to do is get into something a bit more complex. Okay. And what I'm going to be doing is I'm really going to be focused on video search and summarization. So this is something we're seeing as a use case. And I haven't decided if I'm going to do it on this system or not. I may not be able to do it in this system because of the amount of video memory I have. It's a possibility I can do it if I use different model types. But essentially, what video search and summarization is, it really is around, building intelligent video analytics, right? And you're combining that with vision language models, LLMs, and RAG as an example, right? And what you're doing is you're trying to get real-time actionable insights into video, whether it's a video that you've uploaded into the system for analysis, or it's live streamed from, say, an RTSP URL from a camera, as an example. And imagine just that, I look at this use case. So one of the things that I enjoy, or I guess I say I enjoy, a lot of people will say it's kind of dark, but I watch a lot of detective documentaries, right? Not stories so much, but more real life documentaries. And I think in another life, I probably would have been a cop and been a detective, because that job, it really is one of those careers that I think, while it would be very hard, and I feel bad for those guys and those gals that actually do the job. And it takes a certain individual to do it, no doubt about it. Very detailed, very detail oriented. Takes a step back, thinks outside of the box. That's what I love about that career, right? Anyway, imagine what we could have done with, let's just use an example as the DC pipe bomber, right? All the video feeds, all of that, and gathered all the video into a single system that could then do analytics. And by the way, I'm not saying the FBI didn't do that to catch the pipe bomber, but imagine if we had some details where we can say, okay, find me the person in all this video, right, that is wearing the gray sweatshirt that they had, the mask, these types of sneakers, which they pointed out, and have AI do that for you. Imagine the time saved. So, one of the things I see, detectives go through is they go to these places, they have to pull this video from all these different sources, and then they have to actually sit there and watch it. That's crazy to me. If they're watching it, I know they're fast forwarding a lot, probably, right? That doesn't save a lot of time. I mean, it saves some time, but it's not saving a lot of time. Imagine if I was able to just dump all that video footage in an AI platform, and then chat with it to say, hey, show me this car, right, with this license plate, in any of these videos, right? And it comes up. I mean, that's game changing from a timing perspective to catch, criminal activity, or even with live streaming through RTSP, catching criminal activity as it's happening, right? So say you have an analytic system that's monitoring all your camera feeds, and it's looking for people that don't have key cards, people that are breaking glass, people that are, committing crimes, right? And I think that is game changing, right? That'll make a much more safer society, and AI can be used for something like that. This is where I think the power of AI is. I mean, we talk about self-driving cars like it's so awesome. We talk about, having a personal assistant at home, robot that's so awesome. I don't really care about those things. What I care about AI and what it can do, think about the healthcare aspect of it, curing things like cancer. Think about what I just talked about with making society more safe. These are the things I think AI can really deliver on, and that's what we really should be focused on. Put aside the self-driving cars, put aside the robot at your home. We don't need that, right? Not yet. Okay? Focus on things that matter to society, and that's keeping people safe and keeping people healthy, right? So again, I hope you enjoyed this week's session. Next week, again, like I said, I'm going to focus on the video search and summarization. I haven't decided if I'm going to run it on this system, like I said, or I'm going to run it on my Nutanix solution using NAI. I may do that instead and get it working on that. So stay tuned for that. And I hope you have a great rest of the weekend and a very productive week ahead. Take care.